Hello students, welcome to Vyas Edification Kota. And this series of NCERT discussion will continue further with Mathematics class 12th. The chapter that we're dealing with is three-dimensional geometry, and this is exercise 11.3. This particular exercise is based on equation of plane and related things for that matter. And along with the questions, yes, we'll be seeing the concepts. The first question, as you can see over here, says that in each of the following cases, determine the direction cosines of the normal to the plane and the distance from the origin. Right? Distance from the origin is also supposed to be found. How will we deal with this? So let's take a look at equation of plane in general. This is what the equation of a plane in Cartesian form looks like. This is what it looks like, right? Okay. What about the direction cosines? So first of all, from this equation, what do I know? This is Cartesian form of equation of a plane. The direction ratios of normal to plane, or simply the direction ratios of the plane. Sometimes we use that kind of terminology. It is actually direction ratios of normal to the plane will be A, B, C. Simply these, right? And if you are aware of the direction ratios of the normal, you can easily think about the direction ratios of direction cosines of the normal, right? That's also simple. What else? If you are aware of this much, then next thing that you are interested in, the distance from the origin. Now distance from the origin in this particular form is actually not a very difficult thing. It can be found. Distance from origin will be nothing but d upon under root of a square plus b square plus c square and a modulus over this. Right? This would be the simply distance from origin of this particular plane in this particular form, as you can see over here. This is using Cartesian form. We can talk about similar thing using the vector form as well. If required, we can deal with that as well. The vector form of equation of a plane will be r vector dot n vector is equal to d. That's one of the ideas, right? Or I could have had, instead of n vector, I could have had r vector dot n cap is equal to d naught, you can say this, right? If this is n cap, then this is d naught over here. And okay, is this distance from the origin? Yes, actually this is distance from the origin. This distance, the same distance from origin. If you have r vector dot n cap, then you get the distance from the origin, and the right hand side will be there, right? Provided this is positive, right? This should be positive for that matter, right? Keep that thing in mind. So with this much amount of information, and for the Cartesian form, can we deal with a z equals to, for this plane, the direction ratios of normal, direction ratios will be, you can see the coefficient of x is 0, the coefficient of y is also 0. So 0, 0, the coefficient of z is 1. These will be the direction ratios of the normal. Distance from the origin will be simply d, which is minus 2 upon under root of 0 plus 0 plus 1 with a modulus. What is that? That's simply 2. That's my answer for this part A, as you can see over here. Simple, yes. Part B, x plus y plus z equals to 1. Implies direction ratios of normal will be coefficients 1, 1, 1. These are the direction ratios. Oh, we needed the direction cosines, is it? Yes, we needed direction cosines, not the direction ratios. Let's take care of that. Square, sum of squares of these will be 1, so we divide with a 1. These are same as direction cosines of the normal. Here we need to take care of direction cosines. So for direction cosines, we need to divide with 1 square plus 1 square plus 1 square and its under root, which is root 3. So this implies that direction cosines will be 1 upon root 3, 1 upon root 3, 1 upon root 3. These will be the direction cosines. Okay. And what about distance from the origin? Distance from the origin will be simply 1 upon with a minus upon square root of 1 square, 1 square, 1 square, which is 3 again. This is d naught 1 upon root 3 is what you get. With the help of Cartesian form, we are finding this, right? Had we tried to solve this question using the vector form, we could have written this particular equation in this particular form first of all, then this particular form, right? Dividing by the magnitude of n, both sides you get this particular form, right? That's what you can do. So let's try and attempt the third question using that idea. Third part, C part, that is 2x plus 3y minus z is equal to 5. This is what you have, right? So can I write it as this is equivalent to r vector dot with 2i cap plus 3 j cap minus k cap is equal to 5. And you can divide with this magnitude over here. This is 4, 9, 1. What is that? 14. So r vector divided by dot multiplied by 2 upon root 14. I cap plus 3 upon square root of 14 j cap minus 1 upon root 14 k cap is equal to 5 upon root 14. So from here you can directly see that the direction cosines will be these 2 upon root 14 comma 3 upon root 14 comma minus 1 upon square root of 14. These will be the direction cosines, and distance from the origin will be 5 upon square root of 14. This and this are my answers for this particular C part. The last part that remains is D, 5y plus 8 equals 0, and for solving that let's make some space over there first, right? Let's solve this over here and this much space. So part D can be handled over here. Part D, we have 5y plus 8 is equal to 0. The direction ratios will be, okay, we are using the Cartesian form. Yes, we can use the Cartesian form. If you want, you can use this particular form as well. Convert into this normal, divide with the magnitude of normal. Magnitude of this, we divide with this and we get the answer, right? Right hand side should be positive, that will give you the distance from the origin directly. Or you can deal with this idea that the coefficient of x is 0, coefficient of y is 5, coefficient of z is 0. These are the direction ratios. You divide with the magnitude of under root 0, 5 square and this. So therefore, direction cosines will be nothing but 0, 1, 0. Right. This is what you get. What about distance from the origin? Distance from the origin will be 0 plus 8 upon under root of 0 plus 25 plus 0 magnitude. What is that? 8 upon 5. That's the distance from origin. That's my answer for this particular part D. These are the direction cosines and that's the distance from origin. So that's the complete solution of part A, part B, part C and part D. You can take a look at this complete solution over here in this particular question. Question number 2 says, find the vector equation of a plane which is at a distance of 7 units from the origin and normal to the vector this. Okay. Vector equation of a plane which is at a distance of 7 units from the origin. So you're dealing with a vector equation, and if you are given, let us say, if you're given the normal vector of the plane, for the plane, if you're given the normal vector and the distance from the origin, let's say this is the origin, if you are aware of this particular distance d naught, then the equation of plane will be r vector dot n cap is equal to d naught. This is the equation of the plane in normal, this particular form, right? And vector equation of plane which has a distance of 7 units. So d naught is equal to 7, n vector is equal to 3i cap 5 j cap minus 6 k cap. So what do I need? I need n cap from here. What is that? Divide with the magnitude of this square, this square, this square, which is 9 plus 36, 45 plus 25 is 70. Under root of 70. 3i cap plus 5 j cap minus 6 k cap is what you have. Therefore, equation will be r vector dot n cap, which is 3i cap plus 5 j cap minus 6 k cap upon square root of 70 is equal to 7. That's my final equation of this particular plane, as you can see over here. That's the answer. Yes, that's the answer of this particular question number 2. Question number 3 says, find the Cartesian equation of the following planes. Cartesian equation is not at all difficult. You simply replace r vector with xi cap plus yj cap plus zk cap and you get the required equation, right? So in this case you have r vector dot ai cap plus b j cap plus c k cap is equal to d. What you need to do is simply replace r vector with xi cap plus y j cap plus z k cap. That implies that dot product with this will imply ax plus by plus cz is equal to d will be the required Cartesian form of the equation. That's the idea behind this, right? So in the first part, A part, what do we have? The equation will become, you replace r vector with xi y cap z cap. So this becomes x plus y minus z is equal to 2. And that's my required answer. Very simple. Similarly in B, using this idea, r vector is replaced with xi cap, yj cap, zk cap. 2x, 3y minus 4k. Minus 4z is equal to 1 will be the required answer. For part C, what do we have? Here we have parameters, right? But once again, r vector will be replaced with same thing. So what will we get over here? S minus 2t x plus 3 minus t y plus 2s plus t z is equal to 15. That's my required answer for this particular plane in Cartesian form, right? That's the equation of the plane in Cartesian form. Let's discuss question number 4. Fourth question says, in the following cases, yes, there are certain number of cases over here. Find the coordinates of the foot of the perpendicular drawn from the origin. How will we deal with this one over here? Let's take a look at this question by drawing the diagram first of all. Let's say there's a plane and from the perpendicular you drop some particular foot of the perpendicular like this. Okay, this is coordinate A, this is perpendicular, right? Now if you see OA is perpendicular to the plane, If OA is perpendicular to the plane, OA is actually along the normal vector, yes. Therefore, OA is parallel to normal vector. That's what you can say, right? Yes. Or you can say that the direction ratios of OA will be same as direction ratios of N, or proportional basically, right? Or you can say if the coordinates of A are xyz, the xyz will be proportional to this direction ratios of this, yes. Or indirectly you can say, okay, N vector is 2i cap, 3j cap, 4k cap. So the coordinates of A will be 2k, 3k, 4k, so that the direction ratios remain proportional, right? That's important. Direction ratios of OA will be 2k, 3k, 4k. Direction ratios of normal will be 2, 3, 4, right? They are proportional. Is that okay? Yes. Once this is okay, then your life becomes very easy. How is that? Because once you have dealt with this much, you can clearly say that point A, which is the foot of perpendicular from origin, lies on the plane. Yes. The equation of plane is 2x plus 3y plus 4z minus 12 is equal to 0. Our only target is to find k. Once we find k, our work is done. We will get the coordinates. So point A, which is 2k, 3k, 4k is required to be found, and for that we need k. And k can be found by substituting this point over here. What does this tell me? This tells me that 2 into 2k, which is 4k plus 9k plus 16k is equal to 12, and that tells me k will be equal to 12 upon 29. This tells me k will be equal to 12 upon 29. Once you are aware with this much, therefore coordinates of A, that is the foot of the perpendicular, will be 24 by 29, 36 by 29, 48 by 29. You can see these are proportional to the normal vector, which is 2, 3, 4. That's my required answer for this particular part A. Fourth B part says that foot of the perpendicular will be simply you can say, okay, this is the plane and this is point A, this is O. So I can take the foot of the perpendicular along the normal as 0, since y coordinate is there, 3k, and z coordinate 4k, right? And this foot of the perpendicular lies on the plane. Therefore 0 plus 9k plus 16k is equal to 6. What does that tell me? K is equal to 6 upon 25. Okay, once you get the value of k, therefore foot of the perpendicular A will be 0 comma 3 times 6, which is 18 upon 25, comma 6 times 4, which is 24 upon 25. That's the required coordinates of this particular foot of the perpendicular in part B. For part C, we have x plus y plus z equals to 1, and once again process is similar, right? So we have the plane, we have the origin, and this is the perpendicular, this is vertex A, and the coordinates will be proportional to this, that is k comma k comma k, and we can substitute A on this plane. Therefore k plus k will be equal to 1, which tells me k will be equal to 1 by 3. Therefore foot of the perpendicular A will be 1 by 3 comma 1 by 3 comma 1 by 3. That's my required answer for this particular part C. In part D, we have 5y plus 8, this. So for the plane, this is A, and the coordinates will be 0, 5k comma k. Sorry, 5k comma 0. There is no z coordinate, right? So x coordinate and z coordinate will be 0. This is perpendicular and this is origin, and this particular point lies on that particular plane. Therefore 0 plus 25k plus 0 plus 8 will be 0, or that tells me k will be equal to 8 with a minus upon 25, this. Therefore vertices of foot of the perpendicular A will be 0 comma 5k, which is minus 40 upon 25 comma 0, which is 0 comma minus 8 upon 5 comma 0. That's my required answer for this particular fourth part D. Question number 5 says, find the vector and Cartesian equations of the planes, vector and Cartesian equation both, that passes through the point this and the normal to the plane is this. Okay, there's a point given and there's a normal given, right? So for any plane, if you're given any particular point, let's say A, whose vector is A vector, and you want to find P, R vector, this is the normal, let's say. So you can simply say this vector is perpendicular to this vector for any R, right? So we'll have R vector minus A vector dot with N vector equal to 0. That's the equation of plane, right? That passes through the point this and normal vector to the plane. This question is similar, right? Both the questions are similar. So let's talk about the first part, part A. This passes through the point this. So A vector is equal to I cap minus 2 k cap. N vector is I cap plus j cap minus k cap. Equation of the plane will be R vector minus I cap minus 2 k cap in the bracket dot with this I cap plus j cap minus k cap. This equals 0. We can also simplify this. We can leave the answer at this stage, or we can also simplify this up to a certain extent by, let's say, multiplying R with this and multiplying these two and taking it on the right hand side. That is also possible. Next, we can find the equation in Cartesian form as well very easily. That's not an issue. So for Cartesian form, what will I need? We'll have to replace R by xi cap plus yj cap plus zk cap, right? Once I do that, so Cartesian equation will look like, mind you, x minus xi cap minus I cap would be x minus 1 I cap, and that multiplied with this will be simply x minus 1. Yj cap, and there's nothing over here, multiplied by this will be simply y. Z plus 2 times k cap, this will be minus z plus 2 over here, is equal to 0, and this gets replaced by x plus y minus z, minus 2 minus 1 will become minus 3, that goes over there, this becomes a 3, and that's my required answer for this question, this part A, as you can see over here. What about part B? Part B, we can handle part B as well in a similar manner. A vector is from this I cap plus 4j cap plus 6k cap. and n vector is I cap minus 2 j cap plus k cap. Therefore, equation vector form will be r vector minus I cap plus 4 j cap plus 6 k cap dot product with n vector, which is I cap minus 2 j cap plus k cap is equal to 0. This is the equation in vector form. In Cartesian form, the equation will be obtained by replacing this with x. So x minus 1 times this 1, y minus 4 times this minus 2. Then you have z minus 6 times this 1 is equal to 0, and that gives me x minus 2y plus z is equal to minus 1 plus 8 minus 6. That is minus 1 minus 6 plus minus 1 plus 8 is 1. So that is a 1 over here, or minus 1 on the right hand side. This is what you obtain. But this particular form can also be obtained in another way. What is that? So r dot with this will be x minus 2y plus z. And this dot with this on the right hand side will give me this. What is that? 1 into 1 is 1 plus 8, minus 8 and plus 6. That's what you'll get over here, minus 1, right? That's a simpler idea of converting this equation in the Cartesian form. Otherwise, the solution is also good, okay? And this is how you have to begin with. Right? That's the complete solution of this question number 5, as you can see over here. Question number 6 says, find the equations of the planes that passes through 3 points, this and this. How do you find the equations of the planes that passes through the 3 points over here? So one of the ideas is to use the Cartesian equation. Cartesian equation can be obtained by using a simple idea. What is that? Cartesian form can be obtained very easily. So if you have x1, y1, z1, or for that matter xi, yi, zi for I equals 1, 2, 3, the Cartesian equation plane can be represented by pi, and that is equal to x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, and you have another vector which is x3 minus x2, y3 minus y2, z3 minus z2. Now which should I take over here? That's the question, right? So idea should be clear in your mind. What are we doing over here? Let's say this is a plane and we have a point A, we have a point B, we have a point C. If these 3 points are not collinear, then another point P, the coordinates of another point P can be found by taking any 3 vectors on this particular plane, and making them coplanar. How do we make them coplanar? Their STP becomes 0. The scalar triple product becomes 0. That's one idea, right? A simpler idea is to find the equation of plane using your direct means. What is that direct mean that I'm talking about? Let me illustrate that direct approach first. The direct approach says that if you know any 2 vectors, AB vector and maybe BC vector, if you know AB and BC vector, then you can find AB cross BC, and that AB cross BC will be along the normal of the plane, right? Pointing in this direction, rotating through BC, and this will give me the normal of the plane. Oh, this goes inside, doesn't make a difference, right? So that will be normal for the plane, AB cross BC. So the n vector is AB vector cross BC vector. That's one thing. Okay. And if I know the n vector and I know another point on the plane, let's call this A point. Okay. So the equation of plane will be R vector minus A vector dot product with AB vector cross BC vector, which is the n vector, right? This equals 0. If you observe, this is nothing but the scalar triple product of one vector which is R minus A. That is nothing but AP vector, right? And AB cross BC along with this. you're taking a scalar triple product and that scalar triple product equals 0, right? That means that these three vectors are coplanar. That's the only simple idea that we're using. So r minus a, do you observe that r minus a will be x minus this x coordinate x1, y minus y1, z minus z1. That's what we'll be having over here. AB vector is x2 minus x1, y2 minus y1, z2 minus z1, and BC vector is x3 minus x2, y3 minus y2, z3 minus z2. That's what you have. Okay, is this the only approach that I can follow? No, I can interchange ABC as well, right? So similarly, these will be slightly different. But one important thing, x should come once. The terms having x should come once, and then the other two terms should be AB vector, BC vector, AC vector, CA vector. You can use any of those, right? That's not an issue. But P vector should be involved with either A, either B, or either C, with anyone, right? So if you want, if you're feeling like, let's talk about one particular thing, we can talk about this particular thing or this particular thing. You can remember this or this to write the equation in Cartesian form or in the vector form, right? So find the equations of the planes that passes through the 3 points, this. So let's do that. Part A, I'll use the equation in the Cartesian form. That looks easy, right? Here also, if I want to find this, I'll have to find this AB cross BC anyhow, right? So for that, it is better we begin with this only directly. Let's do that. X minus x1. The first point is x1. What is that? X minus 1. Y minus 1. Z plus 1. Okay. Then you have x2 minus x1, which is 6 minus 1, 4 minus 1, minus 5, minus or minus 1. 6 minus 1 is 5. 4 minus 1 is 3. And minus 5 plus 1 will become minus 4. Then you have x3 minus x2, this minus this. Minus 4 minus 6 will be minus 10. Minus 2 minus 4 will be minus 6. 3 minus or minus 5 becomes 8. This determinant equals 0. What does that take me? So 8 times 3 is 24 and minus 24 gets cancelled, right? Yes. So that is 0 times x minus 1. Then you have 8 times 5 is 40 and 10 times 4 is also 40. Oh, pretty interesting. That also goes away. Yes, 40 minus 40 is 0. Z plus 1. This is 30 and this is 30. Minus 30 and minus or minus plus 30 goes 0 times Z plus 1, which is also equal to 0. So equations of planes through these 3 points, what do we get? When we are writing the equation of plane, when we are writing the STP, this becomes a 0 equals 0? Yes, this becomes a 0 equals 0. What does that tell me? Okay, there's some issue in these points, right? Maybe these 3 points are just collinear. Yes or no? Maybe. Let's check these points. 5, 3 minus 4 is directly proportional to this. Okay. So x2 minus x1 and x3 minus x2 are directly proportional. Basically, the direction ratios of the two are directly proportional. Therefore, we can simply say that, or you can simply say that the given points are collinear. Since the given points are collinear, what can you comment about the equation of plane? There will be many planes passing through these 3 points. Collinear points imply they lie on a straight line. If these points lie on a straight line, you can pick up, let us say this. If these points lie on a straight line, maybe this edge, then you'll have various planes. One of the planes, then you'll have another plane, then you have another plane, then you have another plane. Many planes passing through these collinear points. That's what you can have, right? So, or the given points are collinear, that's what you can say, and many planes will pass through this particular. We cannot find any unique plane in that case. That's a part A for us. Let's move on to part B now. Part B says, once again, we have 3 points, yes. So let's take a look at this part B. Okay, this is clear. This part B says equation will be, again from here you can note that it will be x minus 1, y minus 1 and z minus 0. Then you will have y2 minus y1, which is 0, 1 and 1. 0, 1, 1. Then here you will have this minus this, which is minus 3, 0, minus 2. And here you can check that since these two are not proportional, Yes, the points will not be collinear, and hence we can find the equation of the plane easily. This tells me minus 2 and this is gone, so minus 2 times x minus 1, then you have y minus 1 and you have 3 with a minus, this becomes y minus 1. With z you have 3, minus of minus 3 becomes 3 times z, which is equal to 0, and the equation will be minus 2x minus 3y plus 3z, and you have 2, 3, which is 5 equals 0, or you can write it as 2x plus 3y minus 3z is equal to 5. This is the required equation of the plane in option B in the Cartesian form. This is the Cartesian form of the equation of plane, right? You can find the vector form using this approach, but this is the Cartesian form. That's the required answer for this part B, as you can take a look at this question over here. Question number 7 says, find the intercepts cut off by the plane 2x plus y minus z equals to 5. How do we find the intercepts, right? So one of the ideas is to write the equation in the intercept form. Now what does an intercept form look like? For a plane ax plus by plus cz equals d, I can easily write the intercepts by dividing with d throughout. The intercept form actually looks like this when you have a plane having intercepts alpha 0 0 on the x-axis, 0 beta 0 on the y-axis, and 0 0 gamma on the z-axis. The equation looks like x upon alpha plus y upon beta plus z upon gamma is equal to 1. This is the form in intercepts, in terms of intercepts. And similarly, this particular equation can be converted in this particular form by converting this to 1. So you divide throughout by d, and you write x upon d by a plus y upon d by b plus z upon d by c is equal to 1. This gives me the z intercept, this gives me the y intercept, this gives me the x intercept. There's another way of finding the x intercept, y intercept and z intercept. For example, for x intercept you can put y and z equals 0, you'll get the value of x, that's the x intercept. That's another approach, and this is one of the approaches. So for this particular question, 2x plus y minus z is equal to 5. What do? We divide by 5 throughout. Once we do that, this is 2x upon 5 plus y upon 5 plus z upon minus 5. That's what you can note, right? I brought this minus below, that's not an issue. This is equal to 1. You also have to bring this 2 over here, right? So x upon 5 by 2, y upon 5, z upon minus 5. They give me the x, y and z intercepts. For example, x intercept will be 5 by 2, y intercept will be 5, z intercept will be minus 5. That's my required answer for this question number 7, as you can see over here. Question number 8 says, find the equation of the plane with intercept 3 on the y-axis and parallel to the ZOX plane. Now parallel to the ZOX plane, what does this imply? Y-intercept 3, for example, this is x-axis, this is y-axis. So y-intercept is 3, this is 0, 3, 0. And since this is XOZ, ZOX plane, this is the horizontal plane, let's talk about this. And when you have a plane parallel to this, can you please observe that the intercept with the x-axis, the intercept with y-axis will be very, very far away, or you can say they will be infinite, right? In other words, you can also say that the y-coordinate will remain constant throughout. For this plane, y-coordinate will remain constant throughout. That's what you can say, right? Parallel to this plane, the x-coordinate and z-coordinate will not change. Only the y-coordinate will x and z-coordinate will keep on changing, but the y-coordinate will remain same since the plane is parallel to ZOX plane, right? So the equation of plane will be y is equal to constant, that is y is equal to 3 over here, from here. Or the other idea, this is my answer. Or in other words, I can just simply say that the x-intercept and the z-intercept are tending towards infinity. So x upon tending to infinity plus y upon intercept 3 plus z upon intercept tending to infinity is equal to 1. Now what is this? This overall becomes 0 plus y upon 3 plus 0 is equal to 1, which gives me y equals 3. This is another idea of dealing with this, and getting obviously the same answer. There's another way of dealing with this. What is that? Since the plane is parallel to the ZOX plane, instead of applying concepts of intercepts, I can also think of applying r dot n, right, in terms of normal vector. Let's find the normal vector. There's a point already given. If I can find the normal vector, I'll be good to go, right? So any vector parallel to the perpendicular to the ZOX plane will be my normal vector. And what is that? That is along the y axis, right? Any vector along the y axis will have just the j component, right? So normal vector will be 0 I cap plus 1 j cap plus 0 k cap. You could have taken L j cap as well. This is simply j cap, right? And r vector minus 0 I cap 3 j cap dot with j cap. R minus a dot n is equal to 0. This is what you'll get, right? And what does that take me? Where does that take me? This is r minus r will be xi plus yj plus zk minus 3j will be y minus 3j into j will be y minus 3 is equal to 0. Either this is the vector form or this is the Cartesian form. Both of them are the equations of the same plane, right? So we have seen various approaches of getting the same answer in this particular question, as you can see over here. Question number 9 says, find the equation of the plane through the intersection of the planes this and the point 2, 2, 1. Okay, so we're talking about intersection of planes passing through the points of intersection of two planes. For example, these are two planes having this line of intersection. And if you want another plane passing through these points, then if this is plane 1, this is plane 2, the equation of this will be P1 plus lambda P2 is equal to 0. That's how you write the equation, right? So let required equation be P1 plus lambda P2, which is 3x minus y plus 2z minus 4 plus lambda times x plus y plus z minus 2 is equal to 0. This is what you need, right? This is the version which is given directly in the book. So we have written it this way, or you can remember it using this approach. And since this passes through the point 2, 2, 1, implies that will satisfy this particular plane. This particular point will satisfy this plane, and we can get the value of lambda. Yes, this is 6 minus 2 plus 2 minus 4 plus lambda times 2 plus 2 plus 1 minus 2 is equal to 0. This goes away. Okay, minus 2 plus 2 goes away. This is 6 minus 4 is 2 plus lambda times, what is this, 3. So that tells me lambda will be equal to minus 2 by 3. Therefore equation becomes, you put minus 2 by 3 and then you multiply by 3 basically, right? So let's put that 3x minus y plus 2z minus 4 minus 2 by 3 x plus y plus z minus 2 is equal to 0, right? And now you multiply by 3 and you simplify. This becomes 9x minus 2x, which is 7x. This is minus 3y and minus 2y is minus 5y. This becomes 6z and minus 2z is 4z. Minus 12 and plus 4 is minus 8 equals 0. This is the required equation of the plane passing through 2, 2, 1. You can check that. 7 times 2 is 14. Minus 10 is 4. Plus 4 is 8. Minus 8 is 0. That's all that you need in this particular question. That's the complete solution of 9th question. Question number 10 says, find the vector equation of the plane passing through the intersection of planes this and this. Once again, we are given equation of two planes, but in the vector form. So in vector form, the equation of family of planes will be actually r vector dot n1 vector plus lambda n2 vector is equal to d1 plus lambda d2. This is what you have, right? And for finding lambda, we will substitute this point. Find it, right? Okay, so what do we have over here? This tells me r vector dot n1 plus lambda n2 is 2i cap plus 2 j cap minus 3 k cap plus lambda times, what do I have? 2i cap plus 5 j cap plus 3 k cap is equal to d1, which is 7 plus 9 lambda. This is what you have, right? If I substitute the point 2, 1, 3 over here, this will be 2 I cap plus j cap plus 3 k cap. I'll have to dot product with this, so let me write the I component, j component, k component separately over here first. So this becomes r vector dot with 2 plus 2 lambda I cap, 2 plus 5 lambda j cap, minus 3 plus 3 lambda k cap. This is equal to 7 plus 9 lambda. You can check the steps once again, right? This is what you have, right? And now I'll substitute the point 2, comma 1, comma 3 implies r vector will be 2 I cap plus j cap plus 3 k cap. Therefore, let me substitute that. This becomes 2 times 2 plus 2 lambda, which is 4 plus 4 lambda. 1 times this is 2 plus 5 lambda, and k component will be 3, that's minus 9 plus 9 lambda, which is equal to 7 plus 9 lambda. That's a step, right? So 9 lambda gets cancelled with 9 lambda. And what else? Do we have anything else? Can we cancel? No, nothing else gets cancelled. You can simplify the equation. 4 lambda plus 5 lambda is 9 lambda. 4 plus 2 is 6, minus 9 is minus 3. That goes over there, this becomes a 10. So lambda becomes 10 by 9. Therefore equation of the plane, which is this, what will that be? Let's take a look at that. R vector dot product with this 2 plus 2 lambda. What is that? 2 lambda will be 20 by 9. 2 plus 20 by 9, which is 9 into 2, 18 plus 20 is 38 by 9. I cap. Then you have 2 plus 5 lambda. 9 to 18 plus 50 is 68 by 9 j cap. Then you have minus 3 plus 3 lambda, or lambda minus 1 will come into picture. Lambda minus 1 is 1 by 9 into 3 is 1 by 3, or 3 by 9 for that matter, right? This is 3 by 9 j k cap is equal to 7 plus 9 lambda, which is 7 plus 10, 17. This is what you obtain. Or I can write it as, this is the answer, or you can write it as r vector dot 38 I cap plus 68 j cap plus 3 k cap is equal to 17 times 9, which is 153. This or this will be my final answer over here in this particular question. Question number 11 says, find the equation of the plane through the line of intersection of the planes x plus y plus z equals to 1 and 2x plus 3y plus 4z equal to 5, which is perpendicular to the plane this, okay? Intersection of the two planes, that means family of planes, and perpendicular to this particular plane. Let's take a look at perpendicular to this particular plane. So P1 plus lambda P2 equals 0 is what we are interested in first of all. And what is that? X plus y plus z plus 1, sorry, minus 1. This is not plus 1, this is minus 1. X plus y plus z minus 1 plus lambda times 2x plus 3y plus 4z minus 5 is equal to 0. This is what you have. And if we can find the direction ratios of this particular plane, then we can make it perpendicular to this particular plane and find the value of lambda, right? So direction ratios will be nothing but 1 plus 2 lambda, comma 1 plus 3 lambda, comma 1 plus 4 lambda. And the other direction ratios, this is direction ratio of one plane, the direction ratio of the second plane will be 1 minus 1, 1. For perpendicular, the condition simply says that a1, a2 plus b1, b2 plus c1, c2 is 0, right? So 1 plus 2 lambda minus 1 minus 3 lambda plus 1 plus 4 lambda is equal to 0. What does that give me? 4 plus 2, 6 minus 3 is 3 lambda plus 1 is equal to 0, which gives me lambda is equal to minus 1 by 3. I get the value of lambda as minus 1 by 3, right? Okay, once I get this, then I can easily find the equation of plane from here, right? Therefore, equation of plane will be x plus y plus z minus 1 and lambda is minus 1 by 3, 2x plus 3y plus 4z minus 5 is equal to 0. You multiply by 3 and you are good to solve. This becomes 3x, 3y, 3z minus 3 minus 2x. 3x minus 2x will be x. 3y minus 3y will be 0. 3z minus 4z will be minus z. Minus 3 and 5 will be 2 equals 0. This is the required equation of this particular plane in this 11th question, as you can see over here. Question number 12 says, find the angle between the planes whose vector equations are this and this. Okay, angle between planes is not a difficult thing. For example, this is one plane and this is, let us suppose, another plane. So angle between these planes would simply imply, if you know this normal and if you know this normal, you are actually looking at the angle between these two. For example, the angle between this plane and this plane will be this theta will be present over here as well, right? This particular angle will be present. The other angle, which is pi minus theta, will be present over here between the two normals basically. So we're actually interested in the angle between the two normals, n1 and n2. How do we find that? Cos theta will be n1 dot n2 upon magnitude of n1 magnitude of n2. That's using the idea of dot product. Cos theta is n1 vector dot n2 vector upon magnitude of n1 vector magnitude of n2 vector, and you take a modulus to get the acute angle. The other angle will be pi minus theta, right? We generally prefer the acute angle. So this will be n1 dot n2. This is n1, this is n2. So 3 times 2 is 6, minus 6 and minus 15 is what you get in the numerator. In the denominator you get 2 square, 2 square, 3 square. What is that? 4, 4 and 9, which is 17. The other root will have 9, 9 and 25. This is 18 plus 25, which is 43 modulus. And what is this equal to? This is 15 upon under root of, okay, 17 into 43 is what we are supposed to find. 43 times 17, sin 3, 21, 1, 2 carry 7 for 28, 31, 32, 33, 4, 5, 6, 7. 731 is what I get. This tells me theta will be equal to cos inverse 15 upon under root of 731. That's my correct answer for this question over here. That's the correct answer for 12th question. Question number 13 says, in the following cases, determine whether the given planes are parallel or perpendicular, and in case they are neither, find the angles between them. Okay, between the planes, so we are interested in the normal vectors of the planes, and that's what we will take a look at. Right, so once again, the coefficients of x, y, z give me the normal vectors, and first we'll check whether they are perpendicular, whether they are parallel, and after that we'll continue further. Right, so A, or even if you directly find the angle, can we say that we can check the perpendicular or parallel from that particular point? For the planes to be perpendicular, n1 dot n2 should be 0, that is a1 a2 plus b1 b2 plus c1 c2 should be equal to 0. Or in case for parallel, if you find the angle cos theta, for parallel the angle will be simply cos theta will be simply cos 0, which is 1. So cos 0 is 1. If you get that particular case, then you can say the planes are parallel, right? That's what you can say. Or you can directly check whether the coefficients are proportional or not. So what do we have? We have 7, 5, 6 and 3, minus 1, minus 10 as the two direction ratios, right? And are these perpendicular? 7 times 3 is 21, minus 5, minus 60. No. Are these parallel? They do not look parallel. So cos theta can be found by taking 21 minus 5 minus 60 upon under root of this. 756 square, what is that? 49, 36 and 25. 49, 36 will be 85, 85 and 25 will be 110. Then this under root, which is 110. This is 110 again. You take a modulus, and what does this become? This becomes equal to 21 minus 5 is minus 16 and minus, 21 minus 5 is 16. 16 minus 60 is minus 44, right? So this is 44 upon 110 once you remove the modulus. And what does this become? Okay, this is 2 upon 5 dividing by 22 in the numerator and denominator. Therefore, theta is equal to cos inverse 2 by 5. That's the answer for this A part over here. How many more parts are there? There are 4 more parts. Let's take a look at the B part next. B part says, okay, 2, 1, 3 and 1 minus 2, 5 and 2 minus 2 and plus 15. That's what you observe, right? 2, 1, 3 and 1 minus 2. Okay, this is not 5, this is 0 actually. Let's not forget that. There's a 0 over here. There's no 5z, right? That's a simple 5. So if you take a look at cos theta, this becomes 2 into 1, 2. 1 into minus 2 is minus 2 and 0 upon, even if we take anything, this is simply coming out to be under root something which is 0, implies theta will be 90 degree or planes will be perpendicular planes. That's what you can observe in part B, right? Let's take a look at part C next. Part C, we have 2 minus 2, 4 and 3 minus 3, 6. Pretty interesting. This is directly multiplied by 3 by 2. They are proportional, right? They are proportional, yes. So since proportional implies planes are parallel, right? This is what you are getting. What about part D? Let's take a look at part D. In part D we have 2 minus 1, 3 and 2 minus 1, 3. So these are directly same. Since same or proportional, you can say, implies parallel planes, right? What about E, part E? Part E says 4, 8, 1. Let me check this one before. 4, 2 minus 1, 3, 2 minus 1, 3, 2 minus 2, 4, 3 minus 3, 6. And here, okay, we take care of that. That's okay. 4, 8, 1 and this is 0, 1, 1. This is what you have, right? Cos theta. Therefore, part E is what we are taking a look at. Cos theta will be 4 into 0 is 0, 8 into 1 is 8 plus 1 upon under root of 8 square, 4 square, 1 square, which is 81. This is 2. This is what you get under root. This is 9 upon 9, which goes away. So this becomes 1 upon root 2, and that tells me theta will be equal to pi by 4. Cos theta is this, therefore theta will be pi by 4. That's my required answer for part E, as you can see over here. Question number 14 says, in the following cases, find the distances of each of the following points from the corresponding given plane. Distance of the points from the plane. How can you find that? Simple approach. Simple approach, if you remember, a simple result. What's that? For example, if you have a plane and you want to find distance of P, Z1, the perpendicular distance of this particular point from this plane. Right, so PA for this plane AX plus BY plus CZ plus D equals 0 will be PA, this distance will be AX1 plus BY1 plus CZ1 plus D upon under root of A square plus B square plus C square and a modulus. This is the result that we will be using for solving this question over here. Let's take a look at the first part, part A. You want to find the distance of 0, 0, 0 from here. So distance will be equal to 0 plus 0 minus 0 plus 0 minus 3 upon under root of 3 square. Sorry, 3 square is 9. 9 plus 4 minus 4 square is 16 plus 12 square is 144. This becomes, take a modulus, and this becomes nothing but 3 upon 144, and this becomes 169, under root will be 13. That's my answer for this part A. What about part B? Let's take a look at part B. Distance will be again 2 into 3, which is 6 AX1, minus or minus 2 becomes plus 2, 2 into 1 becomes 2 and plus 3 upon under root of 2 square, 1 square, 2 square, which is 4 plus 1 plus 4, and a modulus that tells me D will be equal to, in the denominator you get root 9, which is 3, in the numerator you get 9, 10, 11, 12, 13, 13 by 3. That's my answer for this part. Let's take a look at the part C. D is equal to what? Okay, substitute 2, 3 minus 5 over here. This becomes 2 plus 6 and plus 10 minus 9 upon under root of 144. In the modulus, what does that give me? So this is 18 minus 9, which is 9 upon 3, which is simply 3. That's my required answer for this part C. Part D tells me distance will be equal to what? Let's substitute this point over here. Minus 6 times 2 is minus 12. And you have minus 0 plus 0 minus 2 upon under root of 2 square, 3 square, 6 square, 4 Then you have 9 and 36. What does this become? This is 14 upon 7, which becomes D is equal to 2. That's my required answer for this part D, as you can see over here. So those are the distances. You can take a look at the complete solution once again, and that's what you have in this 14th question. With this, we come to the conclusion of this particular exercise 11.3, based on equation of plane from this chapter 3-dimensional geometry of class 12th. Till the next session, all the best.